Hi, my name is John. Glad you're back. We're going to be doing Chapter 1, Section 4, Trigonometry, this book, 4th edition. It could be 3rd, 4th, 5th, 6th. Most of it is pretty similar. I haven't checked out edition 6 yet, but I have edition 5 and they're very, very similar. So we're going to be going over Chapter 1, Section 4, Introduction to Identities. The cosecant is 1 over sine, the reciprocal. A good way to memorize that, you have to memorize all of these functions because it's going to come out over and over again. In the middle S, there's only one S. Here, of course, there's only one C. Cosine is the reciprocal function. The secant is 1 over the cosine, and you should know that by now from last section. So here we go. Cotangent is 1 over tangent. Sine is 1 over cosecant. Of course, the flip of the cosine is 1 over the secant, and the tangent is 1 over tangent. We are going to be doing one more of these. Let's see how we're going to do something like that. Okay, let's prove one of these. Eeny, meeny, miny, moe, catch a tiger. This one, whatever. So, let's do cosine of the angle. That's equal to, the cosine is adjacent of hypotenuse, x over r. That's the same thing as 1 over r divided by x. Think about why this would be the same as this right over here, the left and the right. If I multiply by x over r, oh, there it is right there. So x over r is 1 over r divided by x is equal to 1 over r divided by x from last section. We know that to be the secant function. Okay, so there we have it. We also need to do a couple more. We have to find out the tangent function and the cotangent. So you got to memorize these and memorize these as well. The tangent of the angle is equal to the sine of the angle over the cosine of the angle. Of course, what's the cofunction of the tangent? Cotangent of the angle. We flip that around, becomes the cosine of the angle over the sine of the angle. I'm going to prove one of them out for you, then you can prove the other one to yourself if you want to. Eeny, meeny, miny, moe. Right there. We'll do this one. The cotangent of the angle is equal to, since the tangent is y over x, opposite over adjacent, y over x, cotangent is x over y. And what we can do at this stage is we can actually just divide the numerator by r, divide the denominator by r, x over r, divided by the quantity y over r. And we know that x over r is going to be the cosine of the angle over the sine of the angle. QED, that was an extremely simple proof. Quadratus demonstratum. Okay, so we're done with that. You can do the other one, the tangent of the angle if you want. Be my guest. Some notations here. Before we do that, so let's actually do one example problem, okay? If the sine of the angle is equal to negative 3 over 5, and the cosine of the angle is equal to 4 over 5, this is example 7 in your book, by the way. What is the tangent of the angle and the cotangent of the angle? Well, you can use x, y's, and r's in your last section if you want. Be my guest. This is the way they want you to do it from the book, and it's going to be a lot easier. You know that the tangent of the angle is equal to the sine of the angle over the cosine of the angle. Wow, look at that. They give that to you. That becomes negative 3 divided by 5 divided by the quantity 4 divided by 5. We have a complex fraction. Make sure you can deal with the complex fraction. We multiply the denominator by the reciprocal, 5 over 4, and cancel that out. Notice that the 5 cancel, numerator, denominator, and that becomes negative 3 over 4. Okay, I'm going to use my highlighter marker for this one. There it is, and there it is. And obviously, let's do cotangent of the angle. It's the reciprocal, which is cosine over sine. We just flip this around, becomes negative 4 over 3. Okay. So cotangent becomes negative 4 over 3. The tangent becomes negative 3 over 4. Now we're going to look at notations a little bit. Notation's going to look a little bit hairy, but once you get used to it, it shouldn't be too bad. Notation. When I go sine squared of theta right there in the middle, that means sine of angle, the whole quantity squared. Make sure you get that notation down. It's going to help you. We don't like to put parentheses if you can, so we put it right in the middle right there. That does not equal sine theta squared. In this situation, the sine of whatever the angle is, you're going to square that angle and get the sine of it. That's not what it means. This right here does not become that, so don't put that square in the with the angle. We want to put it right in between the sine and the angle. So this means that it's a notation. We don't like to put parentheses if you can, so let's get started with one of the examples. Okay. Example. If the sine of the angle is equal to 3 over 5, find sine squared of theta. That's what we're looking for. That means sine of theta, quantity squared. And that means sine of theta is 3 over 5, so we put 3 over 5, quantity squared. And that square that, you get 9 over 25. 3/5 times 3/5 is 9/25. We multiply straight across. Let's do another example. Cosine of the angle is equal to -1/2. I want to find cosine cubed of theta equals question mark. Not that bad. What we do is we put in -1/2 cubed. That's the same thing as -1/2 times -1/2 times -1/2. Negative times negative times negative is negative 1/8. Make sure you can multiply straight across. Multiply straight across in the denominator. You should get negative 1/8. Okay. Let's see. Oh, the Pythagorean identity. This is really important, guys. You should memorize this. This is doubly important. You'll see this Pythagorean theorem in trigonometric form is called the Pythagorean theorem in trigonometric form at least 500 times. So get it memorized. Okay. The cosine squared of the angle plus the sine squared of the angle is equal to 1. This is called the Pythagorean theorem in trigonometric form. So whenever I say Pythagorean theorem in trigonometric form, it's in terms of trigonometric functions. Okay? I'm going to prove this one for you, show that why that comes out the way it comes out. You have a triangle here. You have your x, you have your y value, you have your r value. You should know that from 1.3, and x and y are perpendicular to each other. How do you do that? That becomes, the Pythagorean theorem becomes x squared plus y squared is equal to r squared. Now here's the little kicker. Divide by r squared, divide by r squared, divide by r squared. And that r, I want that to be 1, just like this guy right here. So the only way to do that is divide by r squared. On the left hand side of the equation, I get x over r, quantity squared, plus y over r, quantity squared is equal to 1. What is the ratio of x to r? That was cosine. Oh, there it is. Cosine squared of theta plus y over r, the ratio of that happens to be sine of theta. Since we squared it, we have to square it right there, equals 1. QED. That's what my professor says all the time when I was in graduate school. QED, quadratus demonstratum. Okay, this is the most important one right over here. The Pythagorean theorem in trigonometric form comes in many different flavors. Let's try to solve for sine squared of theta. If I subtract cosine squared of theta, sine squared of theta is equal to 1 minus cosine squared of theta. If I take the square root of the left side and the right side, sine theta equals plus or minus, guys, don't forget your plus or minus, 1 minus cosine squared of theta. You cannot break these out because they are one single term. Two terms, excuse me. Two terms, not one single term. So if one of the flavors looks something like this, or it can look something like this. You can even solve for cosine. As part of your exercises, you will actually have to solve for cosine or sine as well. Okay, one of those two. Okay, the other ones. I'm going to put short notation, sine squared plus cosine squared equals 1. Now what happens is, in this situation, sine squared, same thing, cosine squared plus sine squared equals 1. I'm going to divide by cosine squared. We know that sine squared over cosine squared, or sine over cosine, is tangent. We just learned that. Becomes tangent squared of theta plus cosine squared over cosine squared is 1. 1 over cosine, we just learned that too, becomes a secant squared. Okay? This one will be used quite a bit, not as much. I don't like to memorize this because I can derive it every single time. Pretty relatively easy. The other Pythagorean identity that I have to memorize, let's start again. Sine squared plus cosine squared equals 1. Notice the first time we divided by cosine squared. So what are we going to do this time? Sorry. We're going to divide by sine squared. Let's see what happens. I'm kidding, guys. Sine squared over sine squared is going to be 1. Cosine over sine is the cotangent. Square root of theta. 1 over the sine is the cosecant. So it becomes cosecant square root of theta. So the Pythagorean theorem usually comes in 3 different flavors. I'm going to show you the first flavor. This is the biggest one. You're going to need to see this all the time. The second one is going to be right over here. Tangent square root of theta plus 1 equals secant squared. I don't like to memorize this one because I can always derive it relatively easy, as well as this one. Okay. So there you have it. So let's do some examples here. One of the examples, example 10, if the sine of the angle is equal to 3 over 5 and terminates in quadrant 2, find the cosine of the angle and the tangent of the angle. Okay, let's plug them in. I like to start with the Pythagorean theorem first. I'll use orange. Sine squared of theta plus cosine squared of theta equals 1. I'm going to do it just a little bit different than the way the book does it. I know that the sine of theta is 3 over 5, so it's going to be 3 over 5 quantity squared plus cosine squared of theta equals 1 right there. 3/5 squared is 9/25. I'm going to subtract 9/25, guys, because that turns out to be 3/5 squared is 9 over 25. Subtract that. Cosine squared of theta is equal to 1 minus 9/25 is 25 over 25 minus 9 over 25. That's going to be 16 over 25. And how do I solve for cosine theta? I take the square root. So the cosine of the angle is equal to plus or minus square root of 16 over 25. That's the same thing as here. It's one single fraction or one single